Many worlds, multiverses, are nonsense. If you study any sort of physics or listen to pop-sci presentation, you've probably heard of multiverse theories, that there are lots and lots of different universes that pop out of the probabilities of quantum mechanics. So new multiverses, universes are being formed constantly. Well, this is nonsense, and it's nonsense in the context of any theory. There are string theory multiverses, and string theory is nonsense. Anything related to string theory is nonsense, or almost anything. There, I might give them that there's something that's valid in their thoughts, but most of it's not. But in this particular context, the many worlds theory was the first multiverse theory. It came out of quantum mechanics. And if you study quantum mechanics at all, you probably heard of the Copenhagen interpretation, which came out in the 1920s, and with people in Copenhagen being dominant at the time in quantum mechanics. That's how it's got its name. And it doesn't really have a definition, and what the Copenhagen interpretation means changes with who you talk about and who you talk to. And so I'll discuss a few things related to it, and I certainly won't touch on everything. But it's the idea that you have a wave function, like the Schrodinger equation, and they will say that the wave function collapses and you have a solution. And that solution gives you a result, and it gives you the one solution out of all the probabilities that could occur. And people who use the Copenhagen interpretation usually say the other probabilities vanish at the instant that the solution occurs, because the Schrodinger equation is probabilistic in that you could have multiple different things happen. Now, they don't say how or why it vanishes, except to say that an observer will interfere with the measurement, and an observer will cause the wave function to collapse. So that's one way that it happens, and that's true. When an observer observes what's going on, they interfere with it. They interfere with the experiment. And they can even cause it to give a certain result because they're interfering with it. And that's separate from the result you get if there is no interference. And then another interpretation came along. You have Louis de Broglie, and later Bohm reinforced it, a pilot wave theory, where they thought, oh, wait a minute, there has to be something that causes the wave function to collapse in a certain way. So this is an attempt to bring about more causality into the interpretation. And so they include this idea that there is this wave through space that would guide the result. And this was interpreted to be that there were some hidden variables in space. And that brings up the point that when the Copenhagen interpretation started, there were people that were quantum field and quantum fluctuation deniers. They were working under the assumption that there was no quantum field, there was no quantum fluctuation, there was no medium. So they didn't, without a medium, they didn't have any way to understand how a photon, for example, interacts with its medium, because they thought there's no medium there. They just thought the photon interacted with itself. So they had no means to understand how a photon could come to one result and do one specific thing because it wasn't interacting with anything. Well, now we know that the quantum field is real, quantum fluctuations are real, the photon is interacting with the quantum field the whole time, And you have to include quantum fluctuation interactions. But during that time, they called them hidden variables. So we have hidden variables. Well, if they're calling them variables, they're coming from the standpoint of a mathematician, not a physicist. A physicist says hidden matter or hidden material. And usually when you're talking about hidden matter or material, you're talking about the quantum field. And so that's one of the biggest mistakes the Copenhagen interpretation made, was they didn't consider what's happening in the quantum field. And then in the 1950s, Everett came up with the idea of the many worlds hypothesis, that all the different probabilities occur simultaneously, and that we just happen to live in the one universe where the one result occurs. And once again, this comes down to, well, non-causality, that they didn't consider that there is an actual field that photons and other particles are continuously interacting with, and that those continual interactions determine what results ultimately occur. So that's sort of the basic framework. One can write books about just this and not even cover all the details. And then there are other theories that have developed through the years, and they all have problems. And the main problem with all these theories is two. It's causality and determinism. When you talk about many worlds, you're talking about having no causes whatsoever that determine what the result's going to be. And that's a problem with these interpretations of quantum mechanics. They're not causal. They're not deterministic. They're not scientific. Science is science is based on causality. It's based on observations that one event causes another event, and then additional events cause additional events, and all these different events multiply to give us our causal determinism. Everything that happens is based on a summation of causal events. That's the way science works, and in particular, that's the way physics works. Physics is based on understanding causality. And at the classical scale, we know that causal relationships hold. If you have a billiard ball that's hit by another billiard ball, it moves in a certain direction because of its velocity and momentum and its angle in particular as part of the velocity. And so you have to know those things in order to get the proper result. So the way to think about quantum mechanics from a causality standpoint is to think about it like you would the Feynman diagram. That instead of having a wave function, you have particles. And a particle interacts with another particle. And they both have momentum and angular momentum, and they have their velocities. And based on the type of interaction it is, and the type of momentum and angular momentum, velocities, and other types of parameters, you can determine what it's going to do next. And these are causal relationships. And because you have a specific causal relationship, you get a specific result. And the other results just don't happen. There's no universe that forms for these other results, because a real interaction causes the result that we see. And so in a causal universe, that's the way it works. We have a causal reality. You don't get many worlds and multiverses because there is a cause that gives us the result we see, and the other results simply don't happen. And that is the way I like to think about physics. Because as a science, physics must be based on causality. And that's kind of where quantum mechanics is broken at the most basic level, is that some of these interpretations are not based on causality. And in particular, multiverse theory is not based on causality. And we need to bring causality back into physics. If we don't understand the causes, it means our theories are insufficient. And we need to do a better job understanding the causes. If we want to understand the hidden variables, we need to understand what matter is there that's causing these hidden things to happen. We don't need to talk about mathematical variables like they're non-material substances, that they're not matter. They're matter. There's always matter interacting with matter, causing certain results to happen. So there's a numbers game problem. If we have 10 to the 80th protons and electrons, and if they're changing, say, 1 billion times a second, and I picked that number sort of in the middle because the frequency of electrons is around 10 to the minus 21 seconds and protons 10 to the minus 24 seconds. And so it could be more than 1 billion, but just say they're constantly moving and interacting. And so multiply that times into years, and then the lifetime under the Big Bang model, 13.8 billion years, and I'll just use that as an example to give us a number. And then all of a sudden you're talking about 10 to the 107 multiverses. A lot more multiverses than there are protons in the universe. And that's a huge problem. Where do these multiverses come from? Where do they go? I mean, can you really have a model with over 10 to the 100 power multiverses? Is this a real thing? No, it's not a real thing. This is a logical impossibility. And a couple of the problems with that is it's a huge violation of the principle of conservation of energy. And then we have questions of where does even the space come from? The new space that has to be created. And where does the new quantum field come from? And with both the space and quantum field being effectively infinite for each universe, how do you add infinities to a nearly infinite number of new universes that have to be formed? And the whole thing just doesn't, I mean, it just really looks bad. I mean, this doesn't look like science at all. And really, I don't think it's science. In some of my books, I've done what I call a religion test. And there are different ways that I frame it, but basically, if you have something that is a theory that's unnecessary, and it's an unnecessary complication, which means it makes things worse and more complicated, not simpler. And then if it's not observed, no observations to support it, no experiments to support it, and even worse, not observable, another universe would never be observed by us in our universe, then what we're talking about is not scientific. It's not something, a theory that could be proven using the scientific method, because there's no observations or experiments that would confirm the hypothesis. So the many-world multiverse theory is unscientific. It can't be proven scientifically following the scientific method. It shouldn't even be called a theory. It's no more than a hypothesis. And anyone who believes the hypothesis, given the lack of evidence, it's a religious belief. It's not a scientific belief. And that's the way the multiverses are. It's more fictitious physics. And people who believe it are believing in a religious theory. And then fundamentally, as I say, we have this fight between causality and non-causality. Do we really have a universe where causality doesn't work at the most basic level, at the quantum level? I don't think so. I think that causality is a real thing, and if we don't understand the causal relationships, it means that we haven't done our job as physicists to understand them better. And in most cases, you'll find that people don't take the time to understand what the quantum field is doing. And like all physics problems, if you understand what the quantum field and quantum fluctuations are doing during your assessment of a problem, you will come up with a much better hypothesis about what's going on. Well, I hope you enjoyed this video, and I hope you now understand why I feel that multiverses are nonsense. And please pass this on to your physicist friends and your friends who enjoy science, who like to follow pop-sci crap like multiverse theories, and let them know about the video. And if you'd like to learn more about this, I do have a brief section in my book, The 100 Greatest Lies in Physics, where I talk about many other lies in physics that basically don't correspond with logic or the quantum field's existence. And then I also discuss the positive aspects of how we should view our universe based on the existence of the quantum field in my book, The Zero Point Universe. And then I have my particle theory book on Goodbye Quarks, the Onium theory. And if you read one of my books, that helps support me in my old age and retirement, and which I appreciate, allows me to continue to do more research and make more videos. And if you read my books, I hope you learn a whole lot more. And I'll be doing a few more videos on quantum mechanics. It's a bit tricky because since a lot of it's not well defined, it's hard to pinpoint how to argue about it. But I'll be doing more in the future nonetheless. So thanks for watching.